Welcome back to Cypress Academy Wicked Wi-Fi 101. In the last several videos, I've talked about the fundamentals of encryption and secure sockets. In this video, I will talk to you about X509 certificates. Remember from the previous video that a certificate contains the public key of the certificate authority and the public key of the server you are trying to talk to, along with a signature that's created with a cryptographic hash. Well, there's a standard format for this information called X509. In order for your IoT device to verify the identity of a remote server, you will need to build in the X509 certificate of the certificate authority of your server. In the rest of this video, I'm going to show you what an X509 certificate looks like, how you can get one, how you can look at them, how you can create your own certificates, how to store them in your Wicked firmware, and finally, how to retrieve them for use in your project. Most commonly, X509 certificates are stored in .PEM or Privacy Enhanced Email format. A PEM looks like this. It starts with a begin certificate, then it has a bunch of text in base 64 encoding DER format, then it has a certificate end. That doesn't do you much good unless your brain happens to be able to decode base 64 encoded DER format. But don't despair. There's several ways to decode these files. First, you can use a command line program like OpenSSL. If I run this OpenSSL command on the PEM file that I got from the website http://ben.org, I will see a bunch of stuff, including the public key, who signed it, the expiration date, the signature, etc. I can also look at the information about the certificate by pasting it into SSLshopper.com's website. They have a decoder there, which basically just runs the SSL command for you. On a Mac, you can also look at any website certificate by pressing the little lock button in the Safari browser and then show certificate. When you press details and scroll down, you'll see all the specifics of that certificate. On a PC, in Chrome, you can press the three little dots button, go to the Developers tool, and then View Certificates. Then you can click through all of the information that's available to be looked at in the certificate. So now you know what an X509 certificate looks like and how to examine them. Well, how do you get them? The most surefire way, in my experience, is to download them from the website of the server you're trying to talk to. I'll show you how to do that on http://ben.org. First, I go to https://ben.org. Then I click on the little lock symbol. Finally, I click the certificate and I drag it onto my desktop. This is on my Mac. This file will be a binary DER format, which I can change to a text PEM format by running the OpenSSL command. On a PC, you can follow a similar process. First, you load the website. Then you go to the Developer tools. Then you view the certificate. And finally, on the Details tab, you can click on the Copy to File button. And then, once again, you're off to the races. In my textbook on the internet, you can look at each of these steps with several different OSs and browsers, and I show step-by-step screenshots of all of the pieces you need to get your certificate. If you want to create your own secure server, you can run OpenSSL to create your own self-signed certificates. OpenSSL is built into the Mac and to Linux and can be downloaded into Cygwin on PCs. You should be aware that if you self-sign a certificate, there are some systems which won't trust it because they won't have the certificate authority built into their software. There are three techniques for putting a certificate authority's root certificate into your Wicked firmware. The first technique is to install it into the device configuration table. Remember the DCT which we talked about in Chapter 5? To make this work, you will first need to convert the certificate to PEM format. Then store that file in resources/app/your app. Then you'll need to add the certificate key to the makefile like this. Then, in your program, you can load the certificate out of the DCT using WICED DCT read lock. Finally, you can register the certificate using WICED TLS init root CA certificate, which I will talk more about in the next video. The second technique is to store the certificate in the resources file system. To do that, convert the certificate to a PEM file. Save the file into resources/apps/your-app directory. Add the makefile target name resource to your makefile. Then you will add a #include resources.h to your project. Then you can load the certificate using the WICED API, resources get read-only buffer. And finally, register the certificate using WICED TLS init root CA certificate. The last technique is painful, and I'm not a huge fan of it. However, you can hand edit the PEM file to be a C character array with \r\ns at the end of each line. It will look just like this. Then you can embed that character string into your program, and finally call WICED TLS init root CA certificates on that string. Now that you know about X509 certificates, in the next video we're going to build a real end-to-end secure server by modifying our earlier project. As always, you can post your comments and questions in our Wi-Fi developer community, or you can email me at alan_hawes@cypress.com or tweet me at AskIoTExpert. Thank you.